evening to all distinguished panelists and participants. Bharati Vidyapeeth's Institute of Computer Applications and Management BVI CAM, in association with Computational Intelligence Society CIS chapter of IEEE Delhi section, Computer Society Computer Society CS chapter of IEEE Delhi section, Technology and Engineering Management Society TEMS chapter of IEEE Delhi section, System Man and Cybernetics SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology, Site Standing Committee of IEEE Delhi section, Region 10 of IEEE, with the Associations of Computer Society of India CSI, Institute of Information Technology Professionals IITP, ISTE Delhi section and IETE Delhi Center as technical collaborators. Welcome you all to the IEEE IETE BVI CAM Technical Lecture Series on Cloud Computing Technical and Business Perspective. With immense pride and honor, we are delighted to announce that we, with united hands, mark special contribution for the monumental occasion, Golden Jubilee celebrations of the IEEE Delhi section. From May 13th, 2025 to 12th May 2026, we mark 50 years of this vibrant and pioneering section, a journey that began in 1976 and has since shaped the technological and professional landscape of Northern India through innovation, collaboration, and learning. This webinar today is an initiative to celebrate this legacy. According to Vivek Kundra, federal CIO, United States government, there was a time when every household, town, farm, or village had its own water well. Today, shared public utilities give us access to clean water by simply turning on the tap. Cloud computing works in a similar fashion. Just like water from the tap in your kitchen, cloud computing services can be turned off or on quickly as needed. This shows that the power of sharing resources. Cloud computing is the on-demand access of computing resources, physical servers or virtual servers, data storage, networking capabilities, application development tools, software, AI-powered analytic tools, and more over the internet with pay-per-use pricing. Cloud computing has also become indispensable in business settings from small startups to global enterprises. Its many business applications include enabling remote work by making data and application accessible from anywhere, creating the framework for seamless omni-channel customer engagement, and providing the vast computing power and other resources needed to take advantage of cutting edge technologies like machine learning and generative AI. This session will also explore its all round technological dimensions. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first welcome amongst us Professor Emin Huda sir, Director, Bharati Vidyapeeth's Institute of Computer Applications and Management BVI CAM, and Chairperson IEEE Delhi section, to address the participants with his inspiring words. Over to you, sir.
Am I audible?
Yes, sir.
Yeah. Good evening, one and all. At the outset, our today's valued speaker, Mr. Deepak Goel, the Senior Director, Capgemini, who has readily agreed, despite his
Sir, your voice is lost, I suppose.
Yeah, we are not able to hear you, Professor Huda.
Sir, your voice is lost.
Yeah. Dr. Ritika,
Yes,
please
sir.
go ahead because I'm traveling, so please go continue.
Okay. Thank you, sir. Thank you,
Keep
Huda, sir.
onward.
Yes, sir. Thank you, sir. With this, I would now welcome amongst us our expert speaker, Mr. Deepak Goyal, sir, with an e-bouquet. Welcome to the session, sir.
Thank you so much. My pleasure here.
Thank you, sir.
Yeah.
Dear participants, Deepak, sir, is Senior Director at Cape Gemini with over 3 decades of industry experience, worked across customers in broad range of technologies. Currently, Sir is leading a team of product managers with a portfolio of products in various domains. Additionally, Sir is also leading delivery and product strategy in some of the key engagements. In his earlier role, Sir has worked as business development leader, managing business operations and sales. He has extensive experience on new age technologies like cloud, containerization, AI, ML, IT service management, telecom, automation, new industry use cases, and highly passionate about learning and sharing on technologies. We are honored to have you amongst us, sir, and I would now request you to kindly enlighten the house. Over to you, sir.
Thank you so much. And I hope I am audible well enough.
Yes, sir.
Yeah, thank you. And let me see, I will just share my screen. I hope this should be now shareable. I'm sorry, actually, I'm running this WebEx through the browser. So this is the first time running through browser. Somehow it didn't. Yeah, is it visible now?
Yes, sir. The screen is visible and now the PPT is visible.
Okay, thank you so much. Yeah, so it has always been a privilege to come in this forum and be participating here. I have been there as part of attendee as well in
Sir,
various.
sorry to interrupt. You have come back to your screen. The PPT is not visible.
Yeah,
Please share the PPT.
I hope it is now.
Yes, sir. Yes, sir.
Yeah. So thank you for giving me this opportunity. Right, and I have been doing these sessions for some time. Right, I think twice a year, kind. This is a topic I normally choose apart from some others. But this is the core topic, right? So whosoever wants to understand IT, wants to understand the computing world, cloud computing is foundational. It has been there since now many years. But anywhere you would go, to explore other technologies, cloud computing has become kind of a foundation for anything that can be built on top of it. So it's very important for us to understand, and you would see more than technology, it is a lot of business orientations around it, right? How it actually enables other technologies to flourish, right? What are the various aspects, right, which helps this for the for the humanity to be more technologically conversant and so on. So this has become a kind of a de facto, so all of us should know, and I'm pretty sure everybody of us understands it. Maybe this can be just a just a recap of what you already understand. I will try to go a little deep. Right, wherever you have some questions, please do put it in the chat. We'll try to answer those. Right, and I'll try to see how I can connect cloud computing to various other technologies that are new, and so that it gives a kind of a flavor, that I mean, why are we looking at it now, right? It has been so many years that this has been there, and now what is there new into it, right? So let me start. What I will do is, right, we'll go into a little historical background, some concepts, some core technologies, some advanced ones. We'll look at some aspects which makes cloud computing still requiring a lot of focus, specifically related to security and compliance. Right, what are the various key trends, the newer ones, the older ones, advantages and drawbacks that goes with every technology. But I mean, things have moved a lot since many years into this world. Right, what are the various disruptive technologies related to it? Right, and as you know, I mean, whenever we talk about disruptive technologies, right, AI, Gen AI normally comes into play. We will talk about it, how these two are connected. And then, since we have a lot of academia background here in this forum, I put a slide on carriers as well, right? So if you are looking for beginning your career, or even flourishing your career, or maybe diversifying your career into cloud computing, what are the various positions that normally industry has in this world? Right, and believe me, I mean, this is I mean, a lot of times we look at it as that, there are not many new things like quantum, AI, Gen AI, Edge, and so on. That is so tempting. But cloud computing is foundational. Without that, nothing would work. 5G, 6G, whatever you talk about, right? A definition, a little busy slide. I just wanted this to be a less text, but still, okay, let's bear with it. Cloud computing, what is it? Right, delivery of computing services. And this is kind of a table stakes at this moment in the world that are, we are living. Computing services is something that we look forward to as our rights, right? I mean, what is new into it, right? Um, what it does is it enables flexibility and scalability, like two very important factors. Computing services, even my laptop is a computing service, even your mobile phone is your computing service. Whatever you look at, whatever devices you have today in your hand or at your house, everything has a computer services. But how the flexibility and scalability comes across, that is a beauty. And this has been, I mean, this technology has been exploring, right? It is not something that is static, right? As it has advanced, and we'll look at it, what advancement has happened. Now, what are the different aspects that it brings in? On demand, right, which comes from flexibility. Broad network access, that again comes from flexibility. Resource pooling, which is scalability. I mean, all these can be termed into those two factors, scalability and flexibility. Rapid elasticity, which is again flexibility. And measured service, now, which is something new. Maybe you can talk, you can put it in flexibility domain as well. Measured services are related to that whatever I use, I would pay for it, right? I can monitor, I can control, I can optimize. I have all the flexibility to scale up, scale down. And it will be very transparent reporting between me and my provider to I mean, to actually pay for what I use, and only for what I use, right? So that's a basic architecture, the basic umbrella under which cloud computing works. I'll just quickly go across because there are a lot many slides. History and evolution, we have seen it many times, right? It starts from mainframe, and I mean, mainframe computing era that started in 1960s. There is where cloud computing, not exactly as cloud computing, but as a distributed computing actually started, specifically for data processing. And then in the 2000 era we had services model coming up. Amazon Web Services, which you also know as EC2, right? That came up, that launched in this era, right? And that was a pivotal moment when the cloud computing actually exploded, right? And then there are various SaaS applications, and we'll see what SaaS is. There are many applications which you actually use over the internet, right? Which are called as software as a services, which become a very popular model of the cloud. So that's the evolution that has happened. And then there are many things that came, but this is the basic foundation on which everything is being built, right? Uh, if you look at cloud services model, there are three, still remains as three, and you might have seen many more getting added, because a services model, which is as a service, right? That has been so much used in business that you have a lot of as a service, even everything as a service. XaaS is also some nomenclature that goes on, right? So as a service model has been very popular, and that was made popular via cloud services model. But in cloud services, there are three kinds of model. One is infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service, where whenever you want to have some computing power, right, you go to the service providers. It might be Amazon Web Services, Azure from Microsoft, maybe Google Cloud providers, IBM Cloud, and so many. Right? You just go there, you ask for the infrastructure, the resourcing, or the computing, and you access it over the internet, and you do whatever you want with that. Slice of computing resource that are given to you by the provider, right? We can call it as a virtual machine, we can call it as a server, or whatever we want to call it. But that's a computing resource, just like your laptop, your desktop, your mobile phone. That's a computing resource that is given to you as a bare resource, right? And you can deploy whatever you want on it, whatever you want to do with it. That's a infrastructure as a service. You manage everything, right? What is given to you is a slice of computing power. Platform as a service, it has been popular as well, right? Where you get the entire platform, the entire environment to build applications on top of it, right? There are many examples. Google App Engine is a very popular example where a platform is given. You don't have to worry about which OS you're working on, what is a Java runtime environment, or maybe what other runtime environments that are required, various frameworks that are required as part of platform for logging, for access control, and many things, right? What you care about is writing applications. So that is where you get platform, and then infrastructure comes as part of platform, and then you deploy your platform, your software as a service is used as a user, right? So everything that you use over the internet, that's all software as a service. All your emails, right? Anything, all the websites that you actually go through, right? Whether it is Facebook, whether it is Instagram, and all these are software as a service, right? So that software is running at the background, and you are accessing as a user over the internet. I mean, pretty simple. There are various reasons why these as a service models have been very popular, right? I gave a glimpse of while explaining what these models are. IaaS, about resource management, scalability, right? At one time, maybe you would need a virtual machine with 2 cores. Tomorrow, you might need some more storage space and some more cores added to your VMs, right? The third day you might want to decline or scale down, and so on. So all those scalability options are there. Something like you have been given a power of expanding your compute power of your laptop up and down, right? So that's the beauty of how you can leverage these options, and therefore it is cost efficient, because you are being you are being you pay for what you use, right? As an organization or maybe as a user. Platform as a service started somewhere again in 2000s. It's basically for developers who wants to develop applications, business applications, use cases for end users, and deploy it as for their own business, right? So all the application management, the life cycle, and so on, right, that developers can manage, and the tools around it to use it, right, that is all available as part of platform. So you don't have to worry about it. And there are many tools, right, which any business applications when you're deploying, right, those are very common. So that is where the platform is. So I can give examples, but then that will just go in a different direction. So I'll just restrict myself to the concepts here, right? Software as a service, it has shown a lot of growth. Everybody understands what is there. The user doesn't care what is running at the background. The user only cares about that I'm able to get the service from the application that are running, right? It doesn't care about updates. It doesn't care about security. It doesn't care about scaling up, scaling down, and so on. So everything it runs very seamlessly, and this is hosted by the provider, right? So you just go to the internet and access the software there. This chart actually tells you a little bit of a little detail about how the hosting model works, right? So what you see here, on-premise is everything you manage yourself. On-premise is like your server, right, at your desk, like your laptop, which is your own, right? So you manage everything. You manage the networking, the storage, the hard disk, the operating system, various runtimes that you need, the data, the security, and everything that you're managing yourself, right? In the infrastructure as a service, what you internet is these yellow items, right? So that is managed by a service provider, by your vendor, which means the networking, the storage, right? Because you ask for the storage, I need 2 GB, I need 10 GB, or whatever, I need 1 TB of storage. And what kind of storage, right? There are many kinds of storage that are available. What kind of server you need, what kind of compute power you need in the server. So all that is given to you, and then it is virtualized. It is virtualized, given as a VM, and that VM is with you as an infrastructure, and then everything else you manage, right? The operating system, the runtime, the applications, various tools, and so on. So that is what you manage as infrastructure service. Platform as a service, even the tools and the runtimes and the operating system is given by the vendor. What you manage is the data and the application, right? The application that you are developing. So that is how it actually changes. And software as a service is everything managed by the vendor, right? You are the user, you are the end users, and you are actually using that service, over the internet. That's the basic difference between all of these, right? Now, how in cloud computing, one is that, what are the various ways you can access it, and second is what are the various ways you can deploy it, right? So again, as the access side, when you are deploying it, there are again three models to which you can deploy. There are public cloud. What you see is Amazon, Web Services, or Azure, or Google Cloud. These are all public cloud services, right? Where you go to the internet on the public cloud, you manage it, and then of course there are various technologies through which you can restrict that access, you can make it more secure, and so on. But at the end, it is on the public cloud, right? And wherever it is hosted, the infrastructure is hosted, that is available to all of us, right? As a public. In a private cloud services for large organizations, they really don't want any data to go out, even if it is secure. I mean, cloud computing has gone a long way in making security as a de facto standard, and as part of their model. So I don't think people are much. I mean, they are not concerned about security anymore. There might be here and there, but still we see private cloud services for a lot of other reasons, right? Security is one aspect. Data privacy is another aspect, where you would like your own organization data, or maybe your user data, to be stored in your premises itself. So private is cloud computing, that the end user still accesses it over the internet. They can still have a slice of the compute power, but that is very restricted for an organization, right? And even the physical premises on which the servers are deployed, that is very restricted. It is not available for all the public. And there are various examples where you do have private cloud services in big organizations. Hybrid cloud solutions is actually very prevalent, and nowadays when you look at the business and the way businesses are trying to run, they are going for hybrid cloud solutions, and there's a reason to it, right? um, One is, of course, you want to leverage both public and private, various advantages of both the cloud services, right? One is this: for private, any data which is very sensitive data, you would like it to be in the private cloud, right? The compute you would like to be in the public cloud, so that it can scale up and down and can take the advantage of the huge scale that it operates on, right? And the cost advantage and so on. Uh, but then with the Gen AI and AI, specifically machine learning and AI, where you actually use a lot of data set for machine learning algorithms, which are actually user data for training, right? For your contextual model building. So for all that, you require data which is not public data, right? So we have seen that in artificial intelligence areas, hybrid cloud is very prevalent, where the data which is sensitive, which are user data, and still required in your business operations, right? As I said, for training, for your data churning, for various other ways, you manage your data in the private cloud, and you manage everything else which are not that sensitive in the public cloud, right? So when you go into enterprise space in the sense, when you go into a very high level scaled up models, or scaled up business applications, you would see hybrid cloud is very prevalent, right? In terms of, as I said, leveraging both the options. In terms of market share, AWS is leading. I have given you two two statistics here, right? Both from different analysts, but kind of similar. It might change here and there, but kind of similar. And this is from Q2 2025, kind of June 2025 statistics by various analysts. Amazon still commands one third of the cloud space, right? Azure has come a long way. They had declined earlier, but it has come a long way. Somebody between 25, one fourth of this is with Azure. Google Cloud is also kind of one sixth of all the cloud market that they have. And then there are players, right? I would not call them smaller players, because Amazon, Azure, and Google has been playing in a vast area, right? They have been playing into the consumer space, which is end. So today I can go to Amazon Web Services or Azure Web Services and ask for a compute directly, right? But there are many providers who really don't want to play in that area, who want to play but they have industry specific cloud computing offerings, right? For example, Salesforce has it very specific to the CRM space. They still give to the enterprises the infrastructure, not exactly infrastructure, the platform and the software as a services, but they are very restricted to their area. So you might see it is 2%, but still it is big enough for them, and they really want to operate in that space only. IBM Cloud has been into very, very specific industries in the financial industry, right? They have specific cloud offerings for financial market and so on. So that's why we'll not compare it directly as it is, but yeah, from the three big players, they remain available for a much variety of various use cases, and therefore AWS and Azure and Google does command this cloud market in a big way. Let's go into core technologies, right? And I've just given four examples here: virtualization, SOA architecture, which is service-oriented architecture, grid computing, and distributed computing. These has been very popular, and these has been enabling the cloud computing. Right? Virtualization. I mean, you all know, right? Virtualization is like putting up a wrapper on top of your infrastructure and making it accessible in a kind of a black box fashion, right? And even virtualization also means that the server that you have, the physical server that you have, can be sliced into various virtualized machines. It's kind of cutting your server into 10, 12, 40, whatever way, right, servers, and give each of these slices to each of the users. So that's how you are enabling you are enabling distribution. You are enabling that if you don't need the entire server, people can use and reuse, right? So virtualization is a core technology through which cloud computing actually works. Services oriented architecture is not a technology through which you actually give access to the user, but that is a technology on which cloud computing actually runs, right? So you have to develop your application, your business, in a sense that it is like services, right? Which also means, I mean, in a layman's language, service is something like that you get and you pay for, right? But you only pay for what you get. It is not like a fixed cost that even if I'm not using it, I would still incur a cost for it. So service oriented architecture from a business perspective is like you are charged only for what you are using. From a architecture, from a technology perspective, it could mean a lot of things, right? Which means that you make your application more modularized, right? You make it more distributed. So all this goes into technicality of it, but yeah, SOA is one of the key foundation of leveraging cloud computing in a much better manner. Grid computing and distributed computing has been may not be we can't call it as foundation of cloud computing, but these are analogous to cloud computing, and these are the ways cloud computing has come a long way. Grid computing, distributed computing has been flavors of it, right, in various forms. Quickly going through virtualization technologies, right? Resource optimizations, because as I said, servers can be sliced into various virtual machines, and therefore resources are optimized and can be can be provided to users, in a smaller way and in a magnitude in which the user requires. And hypervisors are the technology through which you create and manage your virtual machines, right? It is a bridge between the hardware and the virtual machine. So virtual machine is still an abstraction between what the user uses and what actual hardware is. So hypervisors, and there are many hypervisors, we can go into detail later on sometime. Cloud storage, it has also come a long way, right? So what as a storage is a space where you put your data, right? From a cloud technology perspective, since it is humongous amount of data that we are talking about, humongous amount of data storage, right? Cloud storage has come a long way, right? Earlier, it used to be that with your virtual machine, you would have some storage space, just like you have in your laptop and so on. But now with so much data and data analytics that is required, you are now come to a space where you start calling it a data warehouse, right? Just as a warehouse where you have lot of that are put in, or a lot of items that are put in. Data warehouse, data lake, those are the concepts that have flourished, and various cloud providers are providing those as a platform to do various analytics on your data, right? So storage is not the storage that we want, we had 10 years back. It has come a long way in terms of various things available now. Networking, again, a core component of cloud computing. Virtual networks, right? Virtual network, as it says, it's something on top of physical network, which makes it enabled and which makes it configured and defined in a more software way, right? So software defined networks, you might have heard about as SDNs, that actually created and enabled cloud computing in virtualizing the network, virtualizing various functions in the network, even to the level of the data plane and various other aspects. Load balancers, load balancers also is a very key component of cloud computing from a networking perspective. It provides, so if you have many virtual machines, that load balancer provides you a way to optimize the traffic between those virtual machines, so that one of the machine, and this is a very old concept. It's not exactly related to cloud computing, but you have a load balancer which actually many machines that runs behind the load balancer. It just balances the traffic, right? So that one is not overloaded and the other is not idle, right? So that makes it more performant and make it more available. And if one is down, if one of the machine is down, the others can take up the load, right? So that's the concept of load balancing. Gateway is also similar things, where you have a network element at the edge of the network in the cloud computing. It provides you various other functions specifically related to access control, security with respect to various policies, and so on. So that all this provides a key technology concepts of cloud computing, from a networking perspective. If I go into advanced cloud computing concepts, let's see what all we have. Serverless computing, a very fascinating area, and this also come a long way, right? So serverless computing is again abstraction of everything related to infrastructure for the developers, or for the companies who wants to host their applications, right? So it abstracts the entire server management. Function as a service is one of the way through which you can create you can create some codes that runs as part of some events, right? So if there's an event, and and that event needs to be captured, or that events needs to be managed, or some automation needs to be done, you just write those functions, right? And deploy those functions. So earlier, when we used to do software development, function was part of your application, right? But now functions, as it is called, function is outside the application. It does just one job and does it perfectly. And when it gets invoked as kind of a trigger to an event, right? So that function gets executed, no context builds up, the function dies as soon as whatever it is supposed to do is it has done. So these are the concepts through which you create an abstraction, right? You concentrate on what is to be done, and you add to the scalability part of it. you don't need these functions to run forever, right? Because it would consume space, it would consume network, it would consume many other, I mean, compute, and all that. So you need the functions to be invoked only when it is needed. So that's how the scalability aspects comes in. And if you need thousands of functions to run as part of an event, thousands would be spawned, right? So that's a part of serviceless computing, where you don't, and there's an abstraction to the service all total, right? Microservices, that's again a way of looking at how cloud computing has come a long way. So microservices, as we call as containers as well, right? So microservices is a different concept, but that concept is built into a containers as well, where for an application to be deployed, you have everything together. Whatever you need for application to be run, including your various libraries and everything, you containerize it and deploy it as it is, right? So there is no dependency that are left out. And within the container, you have various microservices that can be spawned in and out. I mean, these are kind of modules, right? So your application can be divided into various modules. And for example, I mean, if your application has a front-end UI, right, and then it has a middleware, and then there's a backend which takes care of the database and all that. That's a typical model that, as an example, goes on, right? Now, if you suddenly see that there are a lot of traffic for the UI to handle, right? There are a lot of traffic in the sense that many users have started accessing your applications, but they are giving wrong password, or maybe there's a burst of malicious traffic that has started coming up. So your UI would need to handle it. So what you would do is your backend, your middleware, everything is idle, but your UI has all the load. So you spawn various UI servers as microservices as much as is needed. If there are 100 instances are needed, 100 instances would be spawned. And then suddenly, if the burst of traffic goes down, it would actually get into the 10. So it's all about flexibility, right? How flexible and how scale you make it. So these are various ways through which you can do it. Right. Edge computing is also, as there are many use cases that are started coming up, right, with the advent of 5G technologies. So edge computing is all about specifically related to doing your data processing at the edge where the data is actually getting generated, right? For example, in your autonomous car, right? So you see a lot of examples where various decisions, various data processing has to be done at the car itself, right? When to apply the brakes, when to actually do the acceleration, when to do this and when to do that. Now, all those decisions the data cannot traverse all over through the network, and then something doing all the analysis and then giving the decision to the automobile. It cannot happen that way. It has to happen then and there in a real time. So edge computing is all about doing that data analytics, or the data the decision making, or locally processing the data locally, right? There's various reasons, right? And with IoT applications, Internet of Things, all your physical devices being internet enabled, this has come a long way. So cloud computing is enabling all this. There are various models through which edge computing can be incorporated into cloud computing in a fashion that the data process, which is critical, which is very sensitive, which is critical, can be done at edge. And then whatever decision has been taken for wider analytics can be shared on the network to the cloud, right? Where wider processing can happen. So that's how the edge computing comes in as well. I don't know how much time I have, Dr. Ritika. Do we have 10 minutes more?
Sure, sir. We still have time.
Okay, thank you. I just want to be on time, right? Security is, I mean, as we all know, right? It's very important. Data security and a lot of other aspects comes into data security. Encryption comes in, access control comes in. What this slides talk about is how the data security and this encryption techniques are built up. There's various techniques. Again, this is also cybersecurity is also an area where a lot of new advancement is happening. It's a very fascinating field of career as well, right? Data security in terms of software, right, in terms of various, I mean, keys, certificates, and so on. But we see now security and encryption also happening through hardware, right? Yeah, I mean, there's hardware security modules, HSMs has come in, which actually provides, specific data security. And HSMs are also, the access to HSM is also given through cloud providers. I mean, AWS has it, Azure has, I don't know whether maybe Google also has it, right? So all these service providers are enabling various ways of data security encryption, and it has gone to a level where now cybersecurity is not that big concern as we had seen maybe 3, 4, 5 years back. 5 years back, cloud computing was not taking up because of specific areas of security, but a lot of things have been actually enabled. Of course, we have to go a long way with quantum computing coming in. Right, there are again, we see various angles to security, and I'll talk about it in the latest slide. There's a very again, a very important aspect that we should be aware of. Regulation and compliance challenges, various regulations, whether it's a geographical regulations, the law of the land, specifically, whether it is an industry regulations, right, for medical, financial industries, right, and so on. So all those regulations and compliance challenges remains as it is. GDPR, which is the Europe standard, right? Zero trust compliance, which is in the US. Similarly, India also has various IT regulations that we have to take care of, right? And various complex regulatory landscape, as I said. Medical industries needs to be HIPAA compliant. The data processing has to be HIPAA compliant. The financial industries has various other regulations and so on. So there are frameworks that these cloud providers do give, but at the end, the service provider would need to be aware of it and need to make sure that these regulations and compliance are taken care of. Identity and access management. This is all about how you do the access control, how you manage various rules, right? How you manage various security in terms of unauthorized access and sensitive information access and so on. So this is again an area in cybersecurity, an area in itself, which if you're interested, you just go into details. Again, various important aspect. Zero trust security models. This came up, I think 5 years back. This actually started from US. So zero trust security model says that you should not trust any device, whether it is internal or external, right? Which also makes sense from an overall security perspective. But there are various regulations around it, which makes it, there are a lot of audit that actually goes into the zero trust security models to make sure that you are compliant to this, right? So any device that is accessing the network, has to have multi-factor authentication. Any user who is actually using it should be given access to data only for the aspects that the user or the role of the user is for. I mean, these are de facto standard, but it makes it much more organized in a fashion that it can be tracked in objective fashion, right? So this is one security model, and enterprises has to make sure they're compliant, as well as they have to advertise as well that they are compliant to the security models for the users to be for the users to be assured that whatever we are using is exactly in those terms. Right. Key trends in cloud computing. Multi-cloud strategies. This has been there for so long. We have not seen many cloud providers flourishing. Those three big ones are there since ages now, right? When cloud computing started. So I don't see this is a very big issue now, as it was some time back. Vendor lock-in, a lot of standardization has happened, right? So that also doesn't remain standardization, specifically in terms of containerizations, right? So when containerizations came in, whatever you develop, that can be hosted. Of course, you need the platform for it. That can be hosted in various other clouds. right? And on top of containerizations like Kubernetes and Dockers, there are many other providers who actually provided the orchestration layer on top of containers, right? So all that, making sure that multi-cloud strategies is not that big now. Whatever you can run in one cloud, more or less you can run it in different other clouds, apart from the way you access your storage, right? AWS would have a different way of storing it, Azure would have a different way, and so on and so forth. But all over, it is not much concern now, right? So I'll just move on. AI and machine learning, as I said earlier, this is an area that cloud computing is focusing a lot, specifically in terms of data analytics, in terms of sensitive data, because earlier what used to happen is, before the AI world, even when cloud computing was there, what used to happen was that the data which is private, the data which is very sensitive, you can have and store it in your premises, right? You don't need that data to go out anytime. Okay, your application is there, just like in hybrid cloud. Your application is deployed in public cloud, your data is there in the private cloud, everything perfectly fine, right? Why anybody would concern? But with AI and machine learning, what is happening is that your data has to travel now. Your sensitive data, your data that that should not be accessible to anybody else, that has to travel. Why that has to travel? Because that has to train the models, right? That has to train and augment various LLMs, in a more contextual fashion. And these models, these LLMs, large language models, these are hosted on a public cloud. These are hosted somewhere else, not in your premises, right? Not for smaller enterprises, at least. So when this happens, the security aspects plays a bigger role, right? When this happens, there are various tool chains, various models, where you have to make sure that what you are doing in terms of traversing this data is actually aligned to various regulatory frameworks and various security frameworks. So this poses a bigger issue, right? But we have come, again, as I said, in security, we have come a long way to address this. Cloud security advancements, I did talk about it already. Encryptions, identity management, right? All this are part of cybersecurity and cloud security. Sustainable and green cloud solutions, yes, this is very important, right? With the climate that we have, and the environment that we are living in, everything that we do has to be sustainable and within the cloud green green ecosystem philosophy. We are seeing that various service providers are at least telling the users, telling the enterprises that what all they are taking care of, because these data centers are actually consumes lot of power, right? Lot of power. It emits a lot of heat. In fact, if you Google, you will find various innovative ways in which a lot of service providers are innovative ways they are using to make sure that they are not heating up the environment in that way. There are data centers that are created under the sea, right? There are data centers that are running just on green technologies, using solar panels and so on. If you go to service providers, you can actually select a VM, select an infrastructure, and it will tell you that this infrastructure comes from a data center which runs on green technology. Okay, so it has come to that level, and that is why it is actually pushing a lot of pressure to the service providers to make sure that they are able to use various technologies through which this still remains sustainable. Okay. Advantages of cloud computing, I'll just go we talked about cost efficiency and scalability, nothing, flexibility and accessibility, right? These are very, again, table stakes. Disaster recovery and data backup, very important, right? And it has been there for ages, right? So when you have mission critical applications, even if not mission critical, if you have applications which cannot afford downtime, which cannot afford being offline for some time, then you need a mechanism through which if something goes bad with one of the applications, something else takes up, right? So that's the disaster recovery. That's a high availability. Maybe you have used that term earlier. High availability is a localized way. So in the same server, if one of the VM goes down, the other VM can take up, right? So that's a high availability. that means that there's an availability even if something goes wrong. Disaster recovery is across geographies. So if you have a data center, you have hosted your applications in maybe Chennai data center, and that whole of the data center goes down, or maybe there's an outage in the Chennai as a city itself, then what happens? You cannot still afford your users to go blank, right? There's so many mission critical work that is happening. So everything from there would actually get transmitted even if your electricity has gone off, right? There's a backup there in some other geography, maybe in India, or sorry, in Delhi, or maybe in Pune, right? That takes it over. So that's and there are various norms of disaster recovery, whether you need 5 nines, 4 nines, 3 nines, and so on, and which makes sure that how many seconds of offline status can you afford over a year, right? So that gives you the kind of disaster recovery mechanism that we're talking about. And for mission critical is very important. I mean, just think of, right, you have a hospital management, or maybe there's a surgery going on, and there's a lot of, I mean, of course it is manual surgery, but nowadays a lot of remote things does happen, right? And suddenly something goes off, and there's no access to data, no access to tools, and so on. What happens, right? Or maybe in an aeroplane space, or I mean, there are many mission critical work that happens over the geographies, right? So it's specifically for that purpose. Drawbacks and challenges: security and privacy, no longer that much, but with a lot of other things coming in, it is still one area. Dependence on internet connectivity, you need an stable internet. I mean, and this is, again, I don't think it's a concern today. Everybody has a stable internet, and which with much more speed, right? So that doesn't now look. Potential for data loss and downtime, yes, it's related to security, but there are ways you can actually make sure that it goes well. I'll just take disruptive technology. Maybe it is a little it might be of area of concern for us. Quantum computing, right? So quantum computing in the cloud, of course, and you can just Google again quantum computing. That's an era that we look forward to. We'll see what happens then, but it would have hundreds of or maybe thousands of much higher speed of compute as we have quantum computing coming in, right? So it's a different way of doing computing. I'll not go into that details, but what I would try to say is that today quantum computers are very rare, right? And they're very expensive. But they are being enabled on the cloud by various providers. IBM has this, I think Amazon has it, and so on. So computing is a way through which you can have access to quantum computers. There's no other way that, you cannot have quantum computers in your data centers. Too expensive at this moment, right? And second thing why it is important, from a computing perspective also, is that quantum computers would have the power to decrypt your data. I mean, the encryption mechanism that we have today, with the power of quantum computing, maybe those that will get actually obsolete. So today what many cyber attackers are, what they're doing is, even if they are not able to decrypt the data, they are still storing it, right? Encrypted data, they're storing it, and they say that we'll harvest it today and we'll decrypt it tomorrow when we have the power, right? So all those mechanisms makes it still cybersecurity an area of concern. Not related that they're able to decrypt it at this moment, but if they even go on and store the encrypted data, with the quantum computing power, we don't know what would happen later on, right? So cybersecurity for this reason still carries on as a big area, right, of concern. Blockchain applications, this is the technology, not much I mean, of course it is, I'm not saying not much use, but it's a various ways of decentralizing security. Right, I'll not go into this detail of blockchain, but blockchain does use cloud computing in a huge way, because all your ledgers, all the ways you provide the access to blockchain platform. There are very blockchain platforms by the service provider as well, that also goes as part of these technologies. 5G and cloud. 5G is enabling cloud computing a lot, specifically in the IoT and edge area, right? So that happens. Now, my last slide: carriers in cloud computing. So if you're looking for carriers, I mean, it's a very fascinating field, right? We do have in the industry, we do have cloud architects, DevOps engineer, cloud security analysts, and cybersecurity data engineer, site reliability engineer, and there are many others, right? But these are the prime ones. Just go through it. It's a very fascinating technology, evolving as it is, as other technologies are, and it is a platform and the base for all other technologies, right? So I'm pretty sure you would be very interested in this. So thank you for listening to me. That concludes my presentation today.
Thank you, sir. Thank you for the enlightening session. I am sure this has enlightened our participants about the scenario of cloud computing and motivated many of them to take up this technology. I have a few questions by the participant. I would like to now take up with your permission, sir.
Yeah, please go ahead.
So first question we have, you talked about sustainability and cloud computing servers, but what is the actual reality? Like cloud computing servers in themselves, they are big things. And whether we take them underwater or wherever we take them, but are they actually environmentally sustainable? Do we actually have technologies which can make these cloud servers and the infrastructure actually sustainable?
Yeah, that's a question, that's debatable question. I mean, it's like automobile, right? So we still have cars, we still have,
Yes.
aeroplanes and trains, and we see that, we need to do more sustainability. I mean, we need to incorporate more sustainable technologies into it so that we are not emitting that much carbon into the ecosystem. That's the way, all the technologies that require power goes. I mean, you have electric vehicles now, right? But even electric vehicles are do need power, right? Even if it is sustainable power, and then how much you are actually going in that direction. But I have seen that, since cloud computing comes from an IT field, right, which is very pro change. So there are various industries, right? So there are industries which doesn't want to change, and which are very slow in terms of change and adopting various technologies. But IT field is something which is ever changing. If you are not changing, you will be left behind, whether it is in terms of tools, whether it is terms of technologies, and so on. So that gives them lot of push, all the service providers, to make sure that they are at the forefront. So today, every enterprise has a zero carbon vision, right, or targets, if I call it. Even countries have a carbon zero targets, right? So as part of it, they go for service providers which actually advertise, or which actually puts all the data around how sustainable their data center is, right? Which data center is sustainable, okay? And they can go and audit those as well, right? And sustainability comes from, just like electric vehicles, sustainability comes from solar panels, making sure that they as I said, there are technologies where you're not emitting heat, and you take to an area where naturally those heat can be absorbed. Undersea is one of the ways. So things are happening, and if we as humanity keep on pushing, the business, the various ecosystems in this, and in this, I mean, it's all about demand and supply. So if we demand, enterprises or service provider will have to supply. So we have to be cautious about that as well.
Absolutely, sir. Very rightly said. So another interesting question I see. How does a common user access these cloud computing services safely? And who imparts the knowledge to the common user?
Yeah, you are actually accessing cloud computing every day, even if you don't realize it, right? So any social media site that you go, you are actually using cloud computing. But I think your question is from an infrastructure perspective rather than software perspective. If it is from software perspective, the provider actually gives you all the security mechanism, whether it is various multi-factor authentication, access control, which gives you all the security. But if it is infrastructure perspective, if you want to develop something of your own and you really want to access your service providers, there are various sites. There are various trial versions, evaluation versions. Even as students, I think they do provide lot of credits for you to go and explore, right? Explore those service providers, Google it, you will find the links, right? And start using it. Security, as I said, de facto security is no longer a concern, right? Security will keep evolving because there are new technologies through which security threats comes in. Quantum is one, right? There would be a lot of other ways through which the security concerns will keep coming, because that is why all the jobs are running as well. I mean, it will keep on, correct? But de facto, like, my password is lost. I mean, those things we should not be concerned about anymore. I mean, we have come a long way.
Absolutely, sir. That is very rightly said. And I think these issues will keep on going, and this technology called cloud will keep growing because sooner or later, I think each one of us would be coming on the cloud. So, gone would be the days that we would be purchasing applications and running it on our machines. And soon we will be accessing everything over the cloud.
Yeah.
So, thank you, sir. Thank you so much for the wonderful session that we have had today. And we will not be ending this session before we thank sir. So, sir, please accept this e-memento from BVI CAM as a token of remembrance for this wonderful session today.
Thank you so much. Thank you.
And we also have an e-certificate. So, sir, thank you so much for this wonderful session today.
Thank you. My pleasure.
Thank you, sir. Dear
Okay. See you.
participants,
Bye.
with this, we come to an end to this wonderful session today. The feedback form link to generate your certificate of participation has already been shared in the feedback in the chat window. I request all the participants, you can please fill in your details carefully. Please do not make a mistake while filling in your details. So please fill in your details carefully and submit the feedback form. Your certificate of participation shall be auto-generated and mailed into your inbox soon. Do not leave this meeting room till the point you do not receive your certificate of participation. Thank you, Deepak sir. Thank you so much for giving us your time and discussing this wonderful details of cloud computing with us today. Thank you, sir.
Thank you. Thank you. Good day. Bye-bye.
Thank you, sir. Okay, sir. So, dear participants, with this, we have come to an end to another wonderful session. I would